Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, I'll be talking about one more important topic that is called bit masking in embedded system. So this is also more important with respect to interview concern. So in the most of the interviews, this questions from this topic also you will get in the interview. So without further delay, let us start today's video. Bit masking in embedded system. It says about the bit masking. So bit masking. So bit masking, what it says, in C programming, bit masking involves the bitwise operation in order to manipulate bits within the integer variable. This is what I have told you just before starting this topic. C programming or embedded C programming will be working in a bitwise operator in order to manipulate different bits in an integer value. Okay, and then the second point, if you see here, we have to use something called as a mask. What is that mask? I'll tell you later. Mask is nothing but a specific bit pattern. We're supposed to use mask. We're supposed to use the mask. That mask is nothing but specific bit pattern. So what is that? I'll give example later before ending this video. So we have to use a mask which is going to specify specific bit pattern in order to set or in order to isolate or in order to perform these operations. In order to isolate, in order to set, in order to clear, or in order to toggle the particular bits. So now what do you mean by bit masking? Bit masking is nothing but in order to set a particular bit or in order to clear the specific bits or in order to toggle specific bits, we are going to use some bit pattern that is called as bit masking. I hope you got an idea what is the definition of bit masking. So in order to achieve this bit masking, we're going to use our bitwise operators that I'll explain later. So why this is required bit masking, I already told. Our microcontroller will be working in a bit control manner. Microcontroller will operate in a controlling the different operations with the help of different bits. So that will be taken care by our bit masking, and bit masking is achieved by bitwise operators. I hope so. This information is clear to all. Now let us go to the bitwise operators. What are the different bitwise operators we're going to use? In our C programming, there are different bitwise operators are there. Out of that, we have to consider here very important, which will be useful for our embedded programming. Only that part we have considered. The first one is bitwise AND operator. We're going to use a bitwise AND operator in our bit masking procedure or bit masking concept. So this bitwise AND we're going to use in order to clear the respective bits. You can see here the bitwise AND operator is used to clear the bits, or it is also used to extract the specific bits. How to do that, I'll give you example later. It is used to clear the bits and it is also used to extract the bits. How can I check and how can I do? You can see here. Now point number 2. If bit in the end masking is 1, the corresponding bit will results the same if original value if it is same. So don't worry about this. I'll explain you in one use case. So just you need to remember only one thing here. AND operator or bitwise AND operator is used to clear the bits. It is used to clear the bits, or it is also used to extract the specific bits. Okay. Next one, OR operator. Bitwise OR operator. So bitwise OR operator is used to set the bits. So your bitwise AND operator is used to clear the bits, and bitwise OR operator it is used to set the bits. How to set that, I'll give you one example, then you will understand. So bitwise AND is used to clear, and bitwise OR operator it is used to set the bits. And then bitwise XOR operation. Bitwise XOR operation we're going to use in order to toggle, like 0 to 1 and 1 to 0. In order to perform any toggle operations, we're going to use XOR operation. And NOT operator we're going to use to invert it. Okay. Then we have, along with that, we have two more important bitwise operators, that is called left shift and right shift. These two are very important operators. Without this, we cannot achieve any bit masking. Okay, so what is the use of left shift operator? You can see here, left shift operator is used to create the mask for the specific bit position. The main, even though if it is a shift operator, but its application is used in the creating the mask with a particular bit position. I'll give you one use case later. Okay, and similar to that, right shift operator is used to extract the range. Right shift is used to extract the range. How to use that, I'll give you one example, then we will see. Okay, so this, yeah, now here you can see this is a general use case in our masking. Usually what will happen if you want to perform any operation on a bit masking, we will be having three parameters. In that three parameters, here you can see this is a one use case or one example to set the bits. Z is equal to, or Z or is equal to X left shift of Y. So what is Z, what is X, and what is Y, I'll explain you in the next step. This is for setting the bits, and similar to that, the second example, if you see here, Z and is equal to negation of X left shift of Y. This is used to reset the bits, or it is used to clear the bits. And if you want to toggle the bits, we have to use XOR operation. So this is a general example. And what is X, Y, and Z? X means the mask value, the left-hand operator here. So what X stands for? X stands for mask value, how many bits need to be masked. And then what is Y? Y stands for position. Just now we have discussed about mask value and mask position. And finally, what is Z? Z stands for destination, our final operand. So now I have table here. If you want to, this is, you can try to understand here, the number of bits required to mask. The first column says number of bits required to mask and binary representation of that, and what is the mask value or hex value for that, mask position, and then actual representation. If you want to create the first example, if you see here, the first row, in the first row I want to create a bit mask of 1 bit. Binary representation is 1 for 1 bit. 1 is a binary number. Mask value or hex value is 1, and mask position, let us keep all 0 at this moment, and when you write it, its actual representation, I'm going to write it like this. So you need to recall our X left shift of Y. So what is this X left shift of Y? Just now I have explained you, X left shift of Y is nothing but there are two parameters. So one is, so what is this? The left side is mask value. How many of mask value means how many bits you need to create a mask, right? And the right parameter, the right side parameter is position, right? The same example, as the same pattern I have taken here. One left shift of 0 or X left shift of Y. X is nothing but mask value and Y is nothing but position. X left shift of Y or one left shift of 0. In this case, I want to create only one bit mask, and then I want to start mask position with 0. Okay, and if you want to set, we have to use OR operator. If you want to clear, we have to use AND operator. And if you want to toggle, I'll write it on the top here. If you want to set the bit, so use OR operator, binary bitwise OR operator, and if you want to clear, we have to use bitwise AND operator, or if you want to toggle, use XOR operator. If you want to set, use bitwise OR. If you want to clear, we have to use bitwise AND, and if you want to toggle, we have to use XOR operator. How to use that I'll show you in the next example. Okay, so this is how. And the next bit, if you observe here, if you want to go for 2-bit masking, if you want to go for 2-bit masking again, so binary representation means 2 bits, right? So I will write it as 1 1, and the equivalent mask value is 3. The binary represent 1 1, in the hexadecimal it is 3. Now the statement actual representation is equal to 3 left shift of 0. Mask position I'm keeping 0 for all. I'm keeping mask value for all 0 as of now. So when you write it in a representation, it looks like this: 3 left shift of 0. Similar to that, if you go on writing for 3 bits, the next example, if I see for 3 bits, binary representation is 111, and its equivalent hexadecimal value is 7. And when you write it in this, it is going to be 7 left shift of 0. Similar to that, if you go for 4 bit, it is 111. Hexadecimal value is F, and when you write it in Excel representation, it becomes F left shift of 0, and it goes on like that. For 5 bit, it is 1F. For 6 bit, it is 3F. For 7 bit, it is 7F. And for 8 bit, it is 111. And mask value is FF. And when you write it in a pattern way, so it looks like this. Right? I hope this is clear to all. So if you have doubts, you please write a comment, and I'll answer that question in the next video. So I hope everyone, you are clear with the bit masking. And finally, I have lost one small topic. With that, I'll wind up the class today. I'll wind up the video today. The same use case, if so, observe here in this column, I have made my positions as 0, but in the second example here, you can try to understand, I made my mask position as 5. Okay, so this is 1-bit masking. This is 1-bit masking. This is 2-bit masking, and this is 3-bit. This is 3-bit. This is 3-bit masking, and this is 4-bit masking. Okay. So please share this video and like this, and subscribe my channel to know more about embedded system. So until then, I'll come up with the next video. Until then, keep watching our channel, know about embedded system. Thank you.